Hi, I'm Ross.
And I'm Alex.
We're about to play the sound matching game. It's a game that requires a lot of skill.
Yes, let's begin.
Do, 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 do. What? Do, do. Oh, dang. Do, do. Oh. Do, do, do. Whoa. Do, do. Do.
Hey!
That's the game. Alex won.
I won. Alright, so here's the main interface for our sound matching game. The black square on the block diagram is our tone generator and analyzer, which is then hooked up into the stepper control motor. How well you match a sound directly affects how many steps the stepper motor takes. And then that is also hooked up to the photosensor, which tells it whether or not it is the VI, if it's covered or not, and if it is, it ends the game. So then this is the sub-VI for the stepper motor. It takes in the number of steps and the direction it takes, and makes a rising and then falling edge, which makes a step. And then it repeats that for the number of steps.
Here's our sub VI to determine whether or not which photosensor was covered. As you can see, we have at the beginning the DAC assistant, and then it has a split which goes to either player 1 or player 2. Then we have set values for our photosensors when it's covered by the paper, which we figured out through qualitative analysis. And then it goes out to true-false statements that determine which player is won. Here's our sub-VI for our sound generator and analyzer. So at the beginning, it picks a random number between 1 and 0 and goes into our first DAC, which it's an icon that creates a sine wave that the frequency can be set or fed in here. And then it goes into our second DAC, which plays our waveform data. And then it goes to our third DAC, which collects acquired sound data. And then as it goes through the circuit, you can see it goes to measure dominant frequency, and then it measures it through another waveform chart, finds the absolute value, expresses the difference as a percent of the target, and goes to the indicator, which calculates your score and records it on a waveform chart. Here's our circuit for our photoresistors. As you can see, there's 2 of them, and during the game, as one player or the other gets points, the flag moves, and once one of these is covered up, that signals to the program or the VI to stop working, which means that that player has won. Here's a picture of our 2 photoresistors wired up to the DAC. These wires pick up the signal from the photoresistor and puts it into the VI. On the left of the DAC, we have our wired in power supply and ground, and on the right, we have the yellow and black wires, which signal our step and direction for our stepper motor.
So here's a top-down view of the stepper motor control unit. On the bottom we have our inputs for the voltage as well as the step and direction that are wired up into the DAC. And then on top is just the wiring for the stepper motor itself. So we have all of those hooked up correctly.